50 years ago, this house was the scene of one of the greatest mysteries of modern science. A mystery so profound that today, thousands of scientists on the cutting edge of physics are still trying to solve it. Albert Einstein spent his last 2 decades in this modest home in Princeton, New Jersey.
And in his second-floor study, Einstein relentlessly sought a single theory, so powerful it would describe all the workings of the universe. Even as he neared the end of his life, Einstein kept a notepad close at hand, furiously trying to come up with the equations for what would come to be known as the theory of everything. Convinced he was on the verge of the most important discovery in the history of science, Einstein ran out of time, his dream unfulfilled. Now, almost a half-century later, Einstein's goal of unification, combining all the laws of the universe in one all-encompassing theory, has become the holy grail of modern physics. And we think we may at last achieve Einstein's dream with a new and radical set of ideas called string theory. But if this revolutionary theory is right, we are in for quite a shock. String theory says we may be living in a universe where reality meets science fiction. A universe of 11 dimensions, with parallel universes right next door. An elegant universe composed entirely of the music of strings. But for all its ambition, the basic idea of string theory is surprisingly simple. It says that everything in the universe, from the tiniest particle to the most distant star, is made from one kind of ingredient: unimaginably small, vibrating strands of energy called strings. Just as the strings of a cello can give rise to a rich variety of musical notes, the tiny strings in string theory vibrate in a multitude of different ways, making up all the constituents of nature. In other words, the universe is like a grand cosmic symphony, resonating with all the various notes these tiny, vibrating strands of energy can play. String theory is still in its infancy, but it's already revealing a radically new picture of the universe, one that is both strange and beautiful. But what makes us think we can understand all the complexity of the universe, let alone reduce it to a single theory of everything?
We have r mu nu minus a half g mu nu r. You remember how this goes. Equals 8 pi g t mu nu. Comes from varying the Einstein-Hilbert action. We get the field equations. And this term, you remember what this is called? No, that's the scalar curvature. This is the Ricci tensor. Have you been studying this at all?
No matter how hard you try, you can't teach physics to a dog. Their brains just aren't wired to grasp it. But what about us? How do we know that we're wired to comprehend the deepest laws of the universe? Well, physicists today are confident that we are. And we're picking up where Einstein left off in his quest for unification.
Unification would be the formulation of a law that describes perhaps everything in the known universe from one single idea, one master equation. And we think that there might be this master equation because throughout the course of the last 200 years or so, our understanding of the universe has given us a variety of explanations that are all pointing towards one spot. They seem to all be converging on one nugget of an idea that we're still trying to find.
Unification is where it's at. Unification is what we're trying to accomplish. The whole aim of fundamental physics is to see more and more of the world's phenomena in terms of fewer and fewer and simpler principles.
We feel as physicists that if we can explain a wide number of phenomena in a very simple manner, that's somehow progress. There is almost an emotional aspect to the way in which the great theories in physics sort of encompass a wide variety of apparently different physical phenomena. So this idea that we should be aiming to unify our understanding is inherent, essentially, to the whole way in which this kind of science progresses.
And long before Einstein, the quest for unification began with the most famous accident in the history of science.